Okay, so yesterday we learned the basics of quadratic functions and vocabulary. We're going to continue on with that, but we're going to focus on the zeros of quadratic function. And we've technically already talked about zeros in last semester, but this is talking about zeros of quadratic functions. The definition is points at which the parabola intersects the x-axis. And it has many names. So if you remember the acronym ROXs, okay, it stands for roots, zeros, x-intercepts, and solutions. On the EOC at the end of the year, they could refer to either one of these four, but they're all talking about the same thing. What it means by roots, zeros, x-intercepts, or solutions is x-intercepts. So on quadratic functions, it'll either have two solutions, which means it crosses the x-axis twice, or it'll have one solution, which means it crosses the x-axis once, or touches the x-axis, or it'll even have no solutions if it doesn't touch the x-axis at all. Okay, so let's first just see if we can identify what these x-intercepts are. So number one, they gave me the equation here, negative 2x squared plus 12x minus 17. And they also gave me a picture of it. But if you look at this picture, I can tell that it crosses the x-axis twice. But the tricky part is, I don't know what those numbers are because it's somewhere between 2 and 3, and it doesn't look like it's quite 2.5. So I'm going to show you how I can do this in the calculator, and then I'm going to show you a formula we could use later. So let's just break this down. So if I type this into my type into y equals negative 2x squared plus 12x minus 17, okay, and you hit graph, we're going to see exactly what they see, okay, but we want to get an accurate answer of what these two x-intercepts are. All right, so what we're going to need to do is on the y equals screen, we're going to need to put in the second line. So what we're going to need to do to find those zeros, okay, if you click second trace, number 2 says 0. That's referring to the zeros, the x-intercepts, the roots, the solutions. So if I click 2, it's going to say the word left bound, and you want to make sure you're on the left, so you have to use your cursors. There's the cursor. I want to make sure I'm on the left of this first intersection, and then I'm going to go over to the right of that 0, and then hit enter a third time, and it'll find my exact 0 value. So this one would be let's just go 2 decimal places, 2.29. Okay, 0, because it's the x-intercept. And then I want to do the same thing for the right side, so I'm going to do second trace, number 2 again, but I want to be on the left of the right 0, and then I want to be on the right side of the right 0, and then hit enter a third time. And this 0 is 3.71, 0. Okay, now you will not see on your assignment today, you won't see them as decimals like this. They'll be more obvious, but it's good to practice on the calculator. So you'll either see it written as a coordinate or you'll see it written as a list like this, where my 2x values would be 2.29 and 3.71. So you'll see it written either way. Because if I look at number 2, let's do another example. Okay, my equation is x squared minus 6x plus 8. And if you notice, I do have two x-intercepts, but these are more obvious to see. So it's not like these where I have to use my calculator to help me. So my first 0 is 2, 0, and my second 0 is 4, 0. Or I could see it written as x equals 2, 4. You could see it written either way. Okay, number 3 is 2x squared plus 16x plus 36. And if you look at it, this graph does not cross the x-axis at all. So this one has no solutions. Okay, it's not a trick. It doesn't cross the x-axis, so no solutions. Number 4, 3x squared minus 24x plus 45. This one does cross the x-axis twice, here and here. And these are obvious, so I don't have to use my calculator. The first one is at 3, 0, and the second one is at 5, 0. Or you can see it written as x equals 3, 5. Okay? Now, if all they give you is the equations, yes, we can use the calculator method I just showed you, but for your assignment today, you're going to need to know how to write a formula for this. And we call this formula the discriminant, okay? And the discriminant is just a way to determine how many solutions there are. It doesn't tell me what the solutions are, but it tells me how many there are. So my formula is D for discriminant equals B squared minus 4AC. Now, if you're wondering what B, A, and C are, remember my standard form is AX squared plus BX plus C. So when I say BAC, I'm referring to these numerical values here. So let's just practice this. Number 7, okay? D equals my B value, which would be 5 squared minus 4, A, which is 1, and C, which is positive 4. Okay, so you have to know how to set up the equation for your assignment for today. So in my home screen, all you have to do is, oops, that's not my home screen, type this in. So 5 squared minus 4 times 1 times 4, okay, and I get a value of 9. Now, let me be clear. This does not mean that it crosses the x-axis at 9. It doesn't mean that there are 9 solutions. That's where I use this right here. Since D equals 9, the discriminant equals 9. If D is greater than 0, then there are going to be 2 solutions. If D is equal to 0, then there are 1 solution. And if D is less than 0, then there are going to be no solutions. So remember what I mean by that? 2 solutions means crosses the x-axis twice. 1 solution means once, and no solution means none. Okay? So since D equals 9 on this first one, it's greater than 0, so that means there are going to be 2 solutions. Okay? Number 8, same idea, x squared minus 3x plus 10. D equals the value of B, which is negative 3 squared, minus 4, the A value, times 1, times C value, which is 10. Okay, so all about the setup, and then I'm going to type this in. So negative 3 squared minus 4 times 1 times 10. And I get D equals negative 31. Since D negative 31 is less than 0, that means this one's going to have no solutions. That means it's not going to cross the x-axis at all. Number 9, D equals the B value, which is 10 here, squared, minus 4, parentheses, the A value, which is 1, times C value, which is 25. So I'm going to type that in. 10 squared minus 4 times 1 times 25. Now this one, I get D equals 0. When D equals 0, that means it's going to have 1 solution. It's going to cross the x-axis 1 time. Number 10, D equals the B value, which is negative 4 squared, minus 4 times A, which is 2, times C, which is negative 3. And notice how I am putting these in parentheses. When I substitute a value for a variable, then I need to put them in parentheses. D equals 40 here. Since D equals 40 and that's greater than 0, that means it's going to cross the x-axis twice. So there are going to be 2 solutions. Okay, 2 more. D equals my B value, which is negative 12 squared, minus 4 times the A value, which is 4, times the C value, which is 9. Again, I'm going to set this up. Negative 12 squared minus 4 times 9. This one I get D equals 0. And if D equals 0, then that means there's only going to be 1 solution, which means it'll cross the x-axis 1 time. Last one, number 12, D equals the b value, which is positive 5 squared, minus 4 times the a value, which is negative 3, times the c value, which is negative 8. Last one, type in 5 squared minus 4 times negative 3 times negative 8. And I get d equals negative 71. Since negative 71 is less than 0, that means it's not going to cross the x-axis at all. It's going to have no solutions. Okay?